Okay, guys, we are in advanced math trig. If you are in the honors advanced math trig, mods 2, 3, or 4, your date in the top left corner is Wednesday, 4/29/20. Again, if you're in mods 2, 3, or 4, the top left corner of your notes that you're taking today, you're going to put Wednesday, 4/29/20. If you are in mod 7, you're going to learn the same material, take the same notes, but your date would be Tuesday, May 5th, 2020. So again, if you're in mod 7, you guys are putting 5/5/20 for the date in the top left corner of your paper. Okay? Now, the title of today's topic or notes says arithmetic and geometric series. Notice I underlined the word series twice. You hear the words arithmetic and geometric, you might be thinking, hey, wait, we've already done these. What's the point? We did arithmetic sequences and geometric sequences. Oh, but today we're doing arithmetic and geometric series. So the first question, of course, is what's a series as opposed to a sequence? So, guys, just go ahead and write your title. Put a little arrow down to make the following note as the first thing on our paper today. The note simply says a series, whether it's arithmetic or geometric, because those patterns will remain the same, or same rules, I guess, so to speak. So no matter what kind of sequence it is, a series is simply a sequence of numbers separated by plus or minus signs instead of commas. So on your paper, highlight that difference. A series is simply still a sequence of numbers. Could be arithmetic, could be geometric, could be Fibonacci, but they're separated by plus or minus signs instead of by commas. Okay? So an easy difference to see immediately. So my examples, I've got 2 of each kind here. Example number 1. What if I wrote 4 plus 7 plus 10 plus 13 plus ... Now, certainly you can see we're going from 4 to 7 to 10 to 13. The numbers are created how? By adding 3 each time. So you'd agree, just as my note says in parentheses, that is an arithmetic set of numbers, right? And the common difference is 3 because you're adding 3 each time. But instead of an arithmetic sequence, as soon as you see, I'm adding each number together, it's an infinite arithmetic series whose difference is 3. All right, and then my other example, second example, says 7 plus 3. Then it goes to -1, -5, minus, etc. Now, if I said, what's the pattern there? Now, remember, you never say subtracting, do you? You don't say, they're subtracting 4 each time. On an arithmetic sequence, you were taught you're always adding the common difference. So it looks like I'm adding -4 each time to create the numbers. And because they're separated by pluses and minuses instead of commas, you don't call it an arithmetic sequence, you call it an arithmetic series whose difference is -4. Agreed? Third example. 1 plus 2 plus 4 plus 8. The numbers are getting bigger and bigger. It looks like I'm taking 1 and I'm timesing it by 2 to get 2. I'm timesing that by 2 to get 4. Timesing that times 2 to get 8. So it's a geometric sequence of numbers, but instead of commas, there's plus signs, and I'm adding all those numbers together. So that is a geometric series, right, whose ratio was 2. Remember, we have ratios and it's geometric and differences when it was arithmetic. And my other example, I've got 8 plus 4 plus 2 plus 1 plus a half plus etc. It's basically that last series, but descending instead of ascending. Now, careful, remember, we never say dividing. We don't say, they're dividing by 2. We say they're multiplying by what? A half. 8 times a half is 4, 4 times a half is 2, 2 times a half is 1, 1 times a half is a half. If I did say, what's the next number? A half times a half would have been 1/4. Agreed? So this, again, because there's plus signs and not commas, is a geometric series whose ratio is a half. So the question becomes not how do you find the next few numbers, okay, and not how do you find the 38th number. We've already done all that. The question becomes, how do you sum a certain amount of these terms together, other than just typing them in a calculator and going until you get to the term you need? So guys, I'm going to ask questions like this today. I'm going to give you, let's say, that first series, and I'm going to say, what's the sum of the first 31 numbers? Oh, well, you certainly don't want to have to write out all 31 numbers and type all 31 into a calculator and add them all together. Of course, we're going to throw another important formula at you. So here we go. Rule number 1. If my series of numbers that I'm adding together is arithmetic, all right, if it's an arithmetic series, then, now put this formula in a box and keep it in your notes. You're creating a nice library of formulas on all this type of stuff. It says capital S sub n equals n parentheses a1 plus an all over 2. Looks scary. Let's interpret that. Forget my first question. Let's interpret this formula. Capital S stands for sum, right? So what if I took an arithmetic series and I said, let's sum the first n numbers together? Oh, so if I said to you, what's the sum of the first 38 numbers, then n would be 38, wouldn't it? So the sum of the first n numbers is found by taking n, timesing it by a group, and inside the group is a1, the first term, plus a sub n, your nth term. So if I did say, what's the sum of the first 38 numbers? A sub n means a sub 38, which what is the 38th number of that sequence? All over 2. Now, it's not as bad as it looks. Let me prove it to you. Here we go. My first question, my first problem that you would be doing. Let's stick with that first series I had, 4 plus 7 plus 10 plus 13 plus ... What if I said, or asked the question, okay guys, write this one down, S sub 12 equals question mark, right? I didn't say what are the next 3 numbers. I didn't say what's the 38th number. I'm asking what's the sum of the first 12 numbers if I added them all together. And instead of writing all 12 of them down and typing them all into a calculator to get the sum, because remember, I could have said what's the sum of the first 112 numbers, and you wouldn't want to do all that. We're going to follow that formula you just put in a box on your paper. So here we go. Let's try it. The sum of the first 12 numbers will be, okay, looking at my formula, since we want the sum of the first 12 numbers, n is 12, isn't it? So that n is going to get replaced by the number 12. And inside parentheses, we've got, look at my pen. We've got a sub 1, the first term of the sequence, which is what? 4 plus, okay, here's the only part you got to be careful on. It says a sub n. So I got to figure out, since n is 12, right? What is a sub 12? A sub 12, my first term is, my 12th term is, I got to figure out what the 12th term of that series is going to be. So how do you do that? Oh, we got to go back to the a sub n formula you were given in the first day of notes when we learned about arithmetic sequences. To find the 12th number, remember the formula. I'll give you a minute. Do you remember what the formula was to find the nth term of an arithmetic sequence? Wasn't it a sub n equals a sub 1 plus n minus 1 times d? So we're going to go over here in our chicken scratch patch, And to find the 12th number in that series, we got to use a formula that we've already been taught. Now, don't panic. A1, my first number, was what? 4 plus, now, some of you careful. It says n minus 1. Obviously, this was a sub 12, so my n is 12. So 12 minus 1 would be 11, times our common difference, which is what? We're counting by threes. So 4 plus 33, remember order of operations, gives me 37. So I went to my chicken scratch patch and found that my 12th term, if I wrote them all out, would have been 37. And that now goes in that blank spot. Okay? So to calculate this and get the sum of the first 12 numbers, now here's what obviously you're always taught, do what's in parentheses first. So I've got 12 dot connected to 4 plus 37, which is what, 41, all over 2. Now guys, you could take 12 times 41 on your calculator and then divide that answer by 2, and that's fine. I'm just going to do this. I'm going to cancel the 2 and change the 12 to a 6. So really all I'm typing in my calculator, 6 times 41, which is 246. And that's what I'd get if I added the first 12 terms together. Okay? All right, let's try another one here. Number 2, example 2. 15 plus 10 plus 5 plus 0 minus 5, etc. Ready? What's the sum of the first 100 numbers? Wow, the sum of the first 100. Now careful, you don't know what formula to use till you first ask yourself what kind of series is that. It's pretty obvious I'm doing what? What's the pattern? I'm adding -5, adding -5, adding -5. So this is indeed an arithmetic series, and the common difference is what? -5. I'm just making a mental note to myself. So since I want the sum of the first 100 numbers, I'm going to jump up to the formula in our box today. So S sub 100 equals, obviously n is 100. Think with me, don't just copy. Parentheses, A1, the first number, is what? 15. Plus, now I need to figure out what is the 100th number. So in my chicken scratch here patch, A sub 100 is, okay, I'm using that formula again, right? Off to the side to calculate the 100th number. So A1, which is what? 15 plus n minus 1. So that'd be 100 minus 1 is 99 times the common difference, which is -5. So on my calculator, I'm going to hit 99 times -5, enter. Now on my screen it says 495, -495, plus the 15, and my total, the 100th number would be -480. So I found that number so I could put it in right here in my formula. All over, remember, 2. All right, let's do what's in parentheses first. -480 plus 15 would be what? What is that, 465? Now, obviously, if that's a 2 and that's 100, I'm going to cross out the 2 and change the 100 to a 50. So bottom line is, on my calculator, I'm going to push 50 times -465 and get -23,250. Wow, is what I would get if I added together the first 100 numbers. Okay? All right, stay with me. Couple more. Number 3, our third example, says 3 plus 6 plus 12 plus 24 plus ... Okay, describe what you're looking at. That certainly looks like a what? An infinite geometric series. Agreed? How come I said geometric? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 2. Oh, I'm multiplying by 2 each time. And I want to know what's the sum of the first 13 numbers. Oh boy, well, since this is geometric, I'm probably going to have a different formula. Agreed? So here we go. Before I attack and solve the problem, you better put a star and write, if my series is geometric, then, okay, here's the second important formula of the day. Put this in a big box. This is the formula I use to find the sum of the first n numbers of a geometric series. You're going to take a sub 1 times 1 minus r to the nth power all over 1 minus r. Okay? Again, not as bad as it looks. Watch. Let's try this problem. It says find the sum of the first 13 numbers of that series. Well, I sure don't want to write all 13 of them out and then add them all on a calculator. I'm just going to go s sub 13 equals. Now watch, that says a1, doesn't it? My first term is what? 3 times, and in my parenthesis, I've got 1 minus, now remember, r is your ratio. My common ratio. Wasn't I multiplying by 2 each time? So my ratio is 2, but I'm raising that to the nth power. And n is what? 13, isn't it? All over 1 minus, and then whatever your ratio is, which we said is 2. Think with me. Now, guys, you can't cross out the 1 minus 2s. It doesn't work that way. Always do what's in parentheses first. So cleaning up this formula, I've got 3 parentheses, 1 minus, and then whatever 2 to the 13th power is. So go to your calculator, hit 2 to the 13th power. Looks like it's 8192. All over, now look, on bottom it says 1 minus 2, doesn't it? Which is negative 1. So the fact that this parenthesis is going to end up being a negative number is not a big issue, because watch, I've got 3 times, well, what is 1 minus 8192? Isn't it negative 8191? All over negative 1, so all that does, the negative 1 cancels out with the negative sign there, right? A negative over a negative is going to give you a positive. So really all you're doing on your calculator, ignoring now the negative signs, is hitting 3 times 8191, giving me 24,573 for the sum of the first 13 numbers. Wow. And finally, number 4, 2 plus 1 plus 1/2 plus 1/4 plus ... What's the sum of the first 7 numbers? Oh boy. Now certainly, I've got 4 of them here, so 7 would only require me to write the 5th one, the 6th one, and the 7th one. Ugh. But then to add all those together, wouldn't I have to get kind of a crazy common denominator to add all these fractions? I think we're better off relying on our formula here. So here we go. First of all, you agree that this is a geometric series. Why? 2 times 1/2 is 1. 1 times 1/2 is a half. 1/2 times 1/2 is... The pattern is I'm multiplying by a half, so my ratio is a half. Just a note, it's geometric. The ratio is a half, and I'm going to go to this formula since it is geometric. So the sum of the first 7 numbers would be, okay, using my formula, A1. The first number was 2, and then I've got 1 minus... Now my ratio, you agree, is 1/2, and I'm raising that to the nth power. So that would be to the 7th power, all over 1 minus whatever my ratio is, which is what? A half. Now guys, be careful. I know you love decimals on your calculators, but look, the original sequence of numbers is written in fraction form. So my answer has got to be in fraction 4. You're not going to add a bunch of fractions up and all of a sudden get a decimal for an answer. So cleaning this up, I've got 2 parentheses 1 minus. If that says 1/2 to the 7th power, doesn't that really mean 1/2 times 1/2 times 1/2 times 1/2 times 1? You get what I'm talking about. Well, obviously 1 to the 7th power is 1. So really on my calculator, all I'm pushing is 2 to the 7th power. So when I push 2 caret 7, I get 128. All over 1 minus 1/2, which is 1/2. Now guys, do what's in parentheses first. You don't need a calculator. If I have 1 and I subtract 1 1/28, what do I get? Well, of course, that's what? 127 1/28. So I've got 2 times 127 over 128 divided by 1/2. Now, obviously, when I take 2, which is understood to be over 1, and times it by 127 1/28, I get, well, I'm pushing 2 times 127. I get 254 over 128 freeze, divided by 1/2. So anytime you're dividing by a fraction, remember we put times, flip it over, and get 2 over 1. So in essence, this 2 cross cancels and the 128 becomes a 64. Now if that's 254 over 64, that reduces into, okay, divide them both what? By 2. So that'd be what? 127 over 32. And I think that would be my reduced answer. In other words, that 32 would have been your common denominator if you would have added all those fractions together. All I did was took 254 over 64 and reduced it. I divided each of them by 2 and got that answer right there. Wow, as the sum of the first 7 terms. Okay? Your homework is found on Schoology as a document or an attachment. So guys, this lesson you just watched, right underneath that on your Schoology should be the homework assignment for this topic. Okay, and I think all it is a couple of arithmetic series, a couple of geometric series, where you're going to try to find the sum of the first amounts of the numbers in that series. So go to your Schoology, go right underneath this lesson you just watched, print out, or at least get up on your screen, the 4 homework problems that you've got for this. Maybe there's 5 or 6, I'm not sure. But if you print it out and take a look at it, you can do your 6 homework problems and approach it just like a quiz. Your goal is to try to get all 6 of those right and practice that formula, okay? Great job. Thanks for hanging in there. We'll see you tomorrow.